Okay, I think we'll get started. It's almost 5:30, so we will start as we go along. Probably they will join us later. Okay. Uh,
Mine's already blurred. Okay.
okay. Can you see my screen? Yes. Okay. So we have here our third lesson on magnets. Okay. Now, as I mentioned just now, P3, last time it used to be a P4 topic, but magnets now has been shifted, especially your batch is the first batch doing the new syllabus for science. So that means when you're doing PSLE, you will be doing the format. I mean the exam format will be what as per this syllabus, this new syllabus. Okay. So magnets is actually considered a primary 3 topic. Yeah. Okay. So we're just gonna do a quick revision. Okay, quick recap on what is magnets. Okay, magnets are special objects that pull. What's another word for pull?
Attract.
Very good. Okay, when you pull something towards you, it's to attract. Yeah. So it attracts objects made of what? This is a two-word answer actually. Claire, you want to try? Objects made of?
Can we fill it in without annotation?
No, but because if you were to fill in your annotation, eventually you'll still be deleted. So maybe you just tell me, I'll help you write it down. Claire, you want to try this question?
Magnetic materials.
Magnetic materials, yes. Okay, objects made, oh, sorry. Objects made of magnetic materials. Such as what and what? Oh, I think we have someone joining us called Brenda. Let me see.
Yeah.
Hi, Brenda.
She's gone.
Hi, welcome to the class.
Oh,
Which? Hi, Brenda.
Hi.
Okay, which school are you from?
Fuha Primary School.
Fuhua Primary School. Okay, I think I do have a few students from Fuhua Primary School. Nice. Okay, basically, I'm teacher Shirley. So just a little bit of background. Actually, Claire and Victoria has been with me. Okay, they've been in this class for quite some time, right? For myself, I'm actually, or rather, I was an MOE teacher in a secondary school. I was an English teacher, but at the same time, I've also been giving primary science and English tuition for almost 12 years. So that's a little bit about me. Yeah, because it's your first lesson, so maybe just would like to, just give you some background. Okay, yeah. So I think what we're doing now actually is magnets. It's actually our third lesson on magnets already, right? And magnets, I think for this year, primary 3 students, you are following the new syllabus. So magnets is actually a primary 3 topic. Yeah, so we will be covering what we do here at 88 Tuition. We have our own curriculum. So maybe different schools, like for example, Victoria and Claire, they might not be doing magnets now in school. Okay, but you can rest assured that we'll definitely finish all the topics required before you do your end of year exam because different schools are doing different topics. Yeah. Okay. Can. All right. Let's continue. Okay. So we are just on the first slide now. Magnets are special objects that attract, right? When you pull something towards you, like for example, the magnet is pulling something towards it, it's actually an attraction. So attract. Made of magnetic materials, okay, such as what are some examples of magnetic materials?
Such as iron and nickel.
Yes, okay. Remember I always say use this acronym is easier. Science is not cool. Okay, but actually it means steel, iron, nickel, and cobalt. Yeah, so these are the magnetic materials. Why do we remember it this way? I think it's easier for you to remember. And at the same time, it's also to highlight that cobalt is a magnetic material, but copper is not. A lot of students get mixed up between cobalt and copper. Copper is not a magnetic material, but cobalt is. Okay, so here are some examples of your magnetic materials. Yeah, so you can say, like, for example, just now Victoria was saying iron and nickel, or you can just say steel and iron. Okay, and of course, these are the examples of the different types of magnets, right? Generally, I think in school you use a lot of bar magnet or U-shaped magnets, sometimes ring magnets. Okay, hardly will you use needle magnet. Needle magnet is usually found in your compasses. Okay, now next one. A magnet can what magnetic materials? Anyone would like to answer this? Claire, you want to try? A magnet can what magnetic materials?
Attract.
Very good, Claire. Well done. Okay. A magnet can attract magnetic materials. And by magnetic materials, we mean your school is not cool, right? Steel, iron, nickel, or cobalt. Okay. Now, next question. A magnet has how many poles, Brenda? How many poles does a magnet have? Okay, if you look at this, yes, correct. So if you look at this bar magnet on the right-hand side, okay, it has two poles, and they are your north and your south poles. Okay, now next one. A freely suspended magnet points in the what direction? Victoria, would you like to try, Victoria?
North and south.
North, south. Okay, usually we put a north hyphen south. It points in the north-south direction. That means it's like a needle, right? It's a needle, and then one side is north, one side is south. Yeah? Okay, next one. A magnet can attract and what another magnet? Claire? Now, this is really important because when you want to test whether an object is a magnet, this is the only way to test. Okay, it has to repel. Okay, it has to repel another magnet. Only if it's a repulsion can we confirm that both items or both objects are magnet, because only magnets repel magnets. Yeah, so this one, it has to be repulsion. Okay, and last question. Okay, the attraction of the magnet is the what at these two poles? Victoria?
Uh, uh, the attraction of the magnet is at the
I'll give you a clue.
strong.
The superlative. It is the strongest.
Oh,
It is the strongest. Okay, it is the strongest as compared to other parts of the magnet. So the two poles are always the strongest, which means that if, let's say, you are to attract something using a magnet, it will attract the most at the two poles. Okay, so that's the part on magnets. Now let's move on to this question here. Melissa places a magnet close to a copper coin. Okay, so let's take note. This is a copper coin. So what does copper coin tell us? Is it a magnetic material or is it not a magnetic material? Remember, your school is not cool.
Magnetic.
Is it magnetic? This C stands for? This C stands for cobalt. Yeah?
The
Okay.
answer is C. The
Okay.
coin is attracted to the
Okay,
magnet.
let's see if the answer is C. You say that the coin is attracted, okay? But this is a copper coin.
Oh my God.
It's non-magnetic. That's why I say sometimes it can get a little bit confusing. So you just need to be very sure. Copper is a non-magnetic material, and magnets cannot attract non-magnetic material. So if it does not attract it, this is wrong. Of course, there's no repulsion, there's nothing. So basically, the coin remains stationary, means it does not move towards it, it does not move away from it. Answer is D. Okay? And the reason is because the copper is not a magnetic material. Are we clear? Yeah? Okay. Any questions? No? Okay, I see a thumbs up. Good. Okay, next question. The diagram below shows the maximum distance at which each magnet attracts the paperclip. Which of the following is the correct order of the strength of magnets? Okay, now, of course, the further you are able to attract the paperclip, right? If you're able to attract the paperclip from a distance, it means that the magnet is stronger. Okay, that means you don't have to bring it so close to attract it. It's very strong. You can pull it from a far distance. Yeah. So of course, if you were to compare, D will be the strongest because D is able to pull the paperclip from the furthest distance. Okay, as compared to B. Right. Okay, so D is the most, followed by B. Then, of course, your A is slightly further. I think it's quite far away from C. So therefore, the answer is D, because the strongest is the one that can attract it from the furthest.
How do you draw so straight?
I use ruler. Yes, of course I have to use a ruler. I can't draw so straight with free hand.
Wait, you mean you use a ruler from your iPad?
It's not an iPad actually. It's something like a table monitor.
So do
So
you use a ruler from that?
it's something that's quite good because then when your hand touches it, it's not like normal screen whereby it will shift the thing. So it will only receive receive information from this little pen here. So if I were to write, then it will just go with it. Yeah. So
Oh.
it's something that we use just to make sure that our lessons are a bit more conducive. Sometimes when we write on iPad, it might just shift. Yeah. And it's very easy because you can just put the ruler on. It's on the table. Okay. Now, next one. The diagram shows a magnet brought near a plastic block. This is very similar to the copper coin. What will happen to the plastic block? Anybody?
It will not move.
It will not move. Why will it not move?
Because it is plastic.
And plastic is a
Non-magnetic material.
very good. Okay. Of course, if it is an MCQ question, you're not expected to give explanation. But sometimes such questions can appear in your open-ended questions in section B. Then you will need to be able to explain. And when you explain, you need to make sure you have your keywords in it. Okay, so the plastic block is non-magnetic material, therefore the magnet will not be able to attract it, so it will not move. Okay. Oh, wait, this one, it should be a glass block. I think there's a typo error.
Yeah.
Okay.
Will not
So
move.
same thing, the glass
Wait,
block.
wait, what?